Okay, hi everyone. We've been working with solving two variable systems yesterday, and should be a little bit of review. But now we want to extend it, and we want to extend it to solving a three variable system. And if you think about a three variable system, your variables are going to be x, y, and z. If any of you guys are video game players, you're going to be doing a lot of this because video games are done in 3D. Also, if you are one of those that likes to put those face filters on, that's all 3D technology also. And this is just the algebraic background to it. So I'm going to walk you through this example, and then tomorrow in class we'll look at a few other examples also. The thing I want to emphasize is that although there are 4 steps here, no one step is difficult. It's just you have to put all 4 of them together. So that's why this is sometimes seen as complex, but it's really not that bad. Okay, so I'm just going to walk through the 4 steps. Here they are right here, and then here's each one broken down into individual parts of the example. Okay, so here we go. Step 1, we want to pick 2 equations and eliminate a variable. All right, so that's just what we've been doing before. The only difference is we have 3 variables instead of 2. What happens when we eliminate one variable is we're still left with 2 variables, which is what we want. So I'm going to pick the top 2 equations right here, and I'm going to eliminate my x. It doesn't matter which variable you eliminate. You just have to make sure whatever variable you eliminate here, you eliminate the same variable there. So let me write down the first 2 equations. 4x plus 2y plus 3z equals 12. And then 2x minus 3y plus 5z equals negative 7. Like I said, it doesn't matter which 2 you pick. You just got to pick 2. Now, as I said earlier, I'm going to eliminate x. So if I multiply this equation by negative 2, that'll give me negative 4x. So over here on the side, I'm going to rewrite the top equation. 4x plus 2y plus 3z equals 12, and then negative 4x. Negative 3 and negative 2 is 6y, and then I get negative 10z equals 14. All right, now we do our elimination process. Our x's are going to eliminate. And so those are going to be gone. And so we add these 2 things together, and I get 8y plus negative 7z equals 26. Okay, that's my first step right there. So I eliminated x's there. Okay. Step 2, pick 2 other equations, and you need to eliminate the same variables. So let's put a little note up here. Same as step 1. Okay. So that variable has to be. So I have to eliminate the x variable. So I'm going to pick the bottom 2 equations here because I can take this one and multiply it by negative 3 and get an opposite of 6x. So I'm going to have 2x, just rewriting them, minus 3y plus 5z equals negative 7. And I'm going to have 6x minus y plus 4z equals negative 3. And I'm going to take this one right here and I'm going to multiply it by negative 3. And when I rewrite that, I get negative 6x plus 9y minus 15z, and I get equals 21. And then I rewrite my second one, 6x minus y plus 4z equals negative 3. And I do the elimination process, and so those cancel. 9 minus 1 is 8y. Negative 15 plus 4 is negative 11z. And 21 plus negative 3 equals 18. Okay, so there's step 2. Now, as we move to step 3, step 3, take the result and eliminate the variable. What we want to do is we want to take each of these results and we're going to combine those and we're going to eliminate one of the variables. Now this one works out really nice because if you look at this, I've got 8y plus negative 7z equals 26, and I got 8y And really this minus 11 over here is plus negative 11 z, just writing it for consistency, equals 18. And what I can do is I can pick one of these two equations and multiply by negative 1 to give me opposites. So this one works out really, really nice. So I'm going to take this one. Why that one? Doesn't really matter. 8y plus negative 7z equals 26. And then I get negative 8y plus 11z equals negative 18. Okay? And now I'm going to do what we've done before. I'm going to add straight down so those cancel. And I get negative 7 plus 11. I get 4z. And that equals 8. And then you do your division and you get z equals 2. All right, I've got a value for z. Now I want to go back to step 4. And I want to backtrack to solve for the other variables. So how do we backtrack? Well, I start with this z equals 2. That's one thing I know. And then what I can do, I can pick one of these two equations right here, plug z in, and that'll do my algebra and solve for y. So I'm going to pick this one. Doesn't matter which one you pick. So 8y plus negative 7z equals 26. I'm going to plug 2 in for z. That's a negative right there. Sorry. So 8y plus negative 7 times 2 equals 26. And 8y plus negative 14 equals 26. Let's do a little math. Add 14 to both sides. And I'll just come over here. We get 8y equals 40. And divide by 8, we get y equals 5. Awesome. Okay? So now we have two of our variables, a value for two of our variables. We gotta now get a value for x. So I've got z equals 2. I've got y equals 5. To figure out what x is equal to, I got to go all the way back up to here. And I got to pick one of these equations right here. And once again, it doesn't matter which one you pick. I'm going to pick this one because there's no negatives in it. So pick the easy one. So go back down here. I'm going to copy down my equation. 4x plus 2y plus 3z equals 12. And I'm going to substitute z equals 2 and y equals 5 into the equation. So 4x plus 2 times 5 plus 3 times 2, and that equals 12. Do a little math here. 4x plus 10 plus 6 equals 12. Or 4x plus 16 equals 12. If I come up over here, let's do this. Let's take away 16, and you get 4x equals negative 4. That means x equals negative 1. Boom. All right, we're done. However, this is a coordinate. This is a three-dimensional coordinate. And in order to write this properly, we want to write it in coordinate form. And so our coordinates, we write it x, and then y, and then z. So that's a coordinate out in space. Negative 1, 5, 2. And that's your final answer. All right, like I said, we're going to go over some specific examples tomorrow. So just 3 examples we'll cover tomorrow. We'll cover this page to show you what happens when we have no solution. You're going to like this because you get to stop halfway through. Many solutions, same thing, because you get to stop when you're halfway through. And then at some point we will